So in this video, we're going to talk a little bit about increasing and decreasing functions, and on when functions increase, when they decrease, when they do neither, and we'll talk about the intervals that they do that. So, got a couple graphs here for you. With the first graph here, the graph is increasing on this interval from A to B. So you can see A is over here, you can see B is over here, and the graph is directly in between and increasing on this entire interval. One of the things that we can do with this is we can determine that if x1, which would be right here, is less than x2, which is right here, then f of x1, which would be right here, must be less than f of x2. Okay, and you can see that this is true. If you have an increased function, as x gets bigger, then your y value must also get bigger. All right, and that's the concept behind increasing functions. You can see a similar idea with a decreasing function. So this function is decreasing on the interval from A to B, and you can see it's going down the entire time from A to B. And similarly, this time if x1 is less than x2, we have the opposite. F of x1 will be less than f of x2 because the function is going down. Okay. And then the last one is the case where it's neither increasing or decreasing, it's constant on the interval from A to B. And with constant, it's neither rising nor falling, so it's just going straight across. And that's a pretty simple case that if x1 is less than x2, then f of x1 is equal to f of x2, because we are neither increasing nor decreasing, we're staying the same the whole time. So you can see the three things there. We can have increasing, decreasing, and constant. Now, not all functions are always increasing or always decreasing. Some increase at some points, and some decrease as well on different points. So let's take a look at a few examples. We're going to analyze these graphically. So we'll take these three things, put them into our calculator, and see if we can determine on what intervals they're increasing and decreasing. And we'll make a little table to save time. All right. So let's start with the first function there. Take out your calculator, go to your y equals, and let's type it in. Okay, you should be familiar with what this looks like. Parabola shifted to the right 4 units. And so you can see with this graph that we have times when the graph is decreasing, then we have times when the graph is increasing. Since we know that this parabola is just shifted over 4 units, we know that the vertex right here is directly at x equals 4. So, increasing, this function is increasing from 4 all the way to infinity, so we can say that. We can write it in an interval. And it's decreasing on the other interval from negative infinity to 4. So, decreasing negative infinity to 4, increasing 4 to infinity. You might ask the question, well, what's happening at 4? Is it increasing or is it decreasing at 4? This is a question that's not for our course. Some people say it's increasing, some people say it's decreasing. We're going to say neither, and so we'll just leave it right here. All right, it's neither it's not constant anywhere in the interval, so we'll leave this one blank. All right, let's look at our next one. This one is the absolute value of x minus 3. So if we go back to our graph, type in absolute value of x minus 3, and take a look. And it looks similar to the last one, except this time it's not a parabola, it's just absolute value function, so it creates the v. On this one we are increasing on a certain value and decreasing on a certain value as well. Looks like we are decreasing from negative infinity all the way until we get to 3. And then we are increasing from 3 all the way to infinity. So you can see with these, you're just pretty much analyzing the graph and determining when it's increasing and when it's decreasing. And it makes it a whole lot easier if you know what these functions look like without even looking at your calculator. Finally, our last graph here is dealing with a couple absolute values. So the first is the absolute value of x minus 4, and then it's plus absolute value of x plus 4. And then we close that off, and then it's minus 10 off at the end. And let's see what we get there. It's a pretty neat graph. You can see that we have actually some constant area in this graph, so it's a little bit better for us. If you hit trace and you find out where it starts over here, where this little vertex is, looks like it's near -4, which makes sense. So we are decreasing from -infinity to -4. And then from -4 all the way to 4, we are constant. And then we are increasing the rest of the time from 4 to infinity. So this is graphs that are increasing, decreasing, and constant, and so you'll be analyzing some graphs and telling me whether or not they're increasing, decreasing, and constant on certain intervals.